Hello and welcome to Cashmatics. In this video I'll be showing you how to differentiate parametric equations. Now if you don't already know how to use the chain rule, the product rule or the quotient rule, then please watch my videos on those first. In addition to this, you'll need to know how to differentiate trig functions, and as before, go and watch my video tutorial on that if you're feeling a bit rusty on it. Anyway, that's enough of that. Grab yourself some paper and a pen and let's get started. So before I do any examples, I want to remind you what parametric equations are. And that's when x and y are both defined in terms of another parameter. It's normally t or theta, but it can actually be any letter. So let's say we've got these ones here. Okay, so in the first example, I've got x equals 2t and y equals t squared minus 3t. So you can work out what x and y are when you know a certain value of t. And in this case, x and y are defined in terms of the parameter t. In the next example, I've got x equals 2 cos theta and y equals sine squared theta. And this time, x and y are defined in terms of the parameter theta. Now, the main thing you need to take away from this is what I've got here in the blue sort of bubble. dy by dx is equal to dy by dt times dt by dx. Okay, and the reason why we can use this is because y and x are both defined in terms of t, so I can differentiate those with respect to t. But then if I use this, the dt's cancel out to leave me dy by dx. Right? And that's a really important rule when it comes to the chain rule. The other thing to remember is when you do differentiate y, you'll get dy by dt. But when you differentiate x, you'll get dx by dt. But what we've got over here is dt by dx, which is the reciprocal of dx by dt. So don't forget to turn it over when you're coming to do your multiplication. Anyway, that's that sorted. Let's do some examples. So I've got a nice simple example to begin with, and I've got the chain rule from the last slide up there in the cloud just under the title. So when we're trying to find the derivative, dy by dx, what we need to do first of all is differentiate x and y with respect to t. So let's just do that first. So dx by dt, now that would be 6t, and dy by dt, that would be 6t squared. So dy by dx will equal, so we've got dy by dt, which is this, 6t squared, times by dt by dx, which is the reciprocal of dx by dt, so multiplied by 1 over 6t. So let's just do some cancelling. I can cancel out a 6, and I can cancel out a t, and that leaves me with just t. Okay, so nice, easy example to begin with. So the second example we do in exactly the same way. Now before I do it, I'm just going to rewrite this as x equals 2t to the power minus 1. It just makes it easier to differentiate. So dx by dt would equal, now remember, multiplied by the power, so minus 2 t to the power minus 2. Remember to subtract 1 from the power, and quite often you can get that the wrong way around. And I'm just going to rewrite it now as 2 over t squared. Now dy by dt will equal 6t. Okay, so that's that one done. So all I need to do now is plug it all in. So dy by dx will equal dy by dt multiplied by dt by dx. Now remember, I need to do the reciprocal, so multiplied by minus t squared over 2, and that gives me minus 3t cubed. Okay, remember the 6 and the 2, you can cancel out a factor of 2. Alright, so that's that one done. Again, fairly straightforward. So the third example is a little bit more involved. dy by dt is straightforward enough. Okay, let's just get that out of the way. dy by dt is just 2, and that's nice and easy. But this here is a product, so we need to use the product rule. So if we say let u equal t squared, and let v equal e to the power t, du would equal 2t, and dv is equal to e to the power t. Now remember, is v du plus u dv for the product rule. So dx by dt would equal u dv, so t squared e to the power t, plus v du, which is 2t e to the power t. Right, okay, so that's dx by dt. And let's just put it all together. dy by dx would equal dy by dt, which is 2, multiplied by dt by dx, which is the reciprocal of all of this. So 1 over t squared e to the power t plus 2t e to the power t. And we could simplify all of this by putting the 2 in the numerator, because that's all there is in the numerator. And in the denominator, I'm going to factorize out an e to the t as well as a t. So t e to the t. And what am I missing here? I'm missing a t in the first term, and I'm missing a 2 in the second term. And that's that one done. Right, so example number 4. We've got some trig in this one. So let's just start as before. dx by d theta. Now, sine becomes cos. Okay, we've got a 3 theta here, so we need to multiply by 3. So let's just do it step by step. It'll be 4 cos 3 theta multiplied by 3, which is 12 cos 3 theta. And dy by d theta, let's have a look at what this becomes. Cos becomes minus sine, and because there's 3 theta, I'd have to multiply by 3 as well. So that would be minus 3 sine 3 theta multiplied by 3, which is going to be minus 9 sine 3 theta. So let's put it all together. dy by dx equals dy by d theta in this case. So minus 9 sine 3 theta multiplied by d theta by dx, which is 1 over this. Okay, and let's just tidy that up. The minus 9/12 gives me minus 3/4, and the sine 3 theta over the cos 3 theta gives me tan 3 theta. Okay, so again, fairly straightforward if you know how to differentiate these trig functions. So this next example is a bit more involved. What we've got over here is a quotient, and what we've got over here is a reciprocal function. So let's do the reciprocal function first, and before I do it, I'm just going to rewrite it slightly differently. So x equals 2t minus 1 to the power minus 1. Alright, so let's do dx by dt first. So remember, this is something to the power minus 1, which will be minus, and I don't have to worry about the 1, 2t minus 1 to the power minus 2. So I've taken 1 off the power. Then I need to multiply by the derivative of whatever's inside, which is 2. Alright, and I'm just going to tidy that up. That'll be minus 2 over 2t minus 1 squared. So I've just rewritten it, which will be easier and a bit more friendly for the algebra when I do the next stage. Let's do the same with y now. Now for y, I've actually got a quotient. Okay, so I'm going to let this bit here equal u, and this bit here equal v. Alright, so u equals t squared, and v is equal to 2t minus 1. So du would equal 2t, and dv would equal 2. And as far as the quotient rule goes, dy by dt is equal to v du. So v du, so that would be 2t minus 1 times by 2t. Take away u dv, so t squared times 2, so that's 2t squared, all divided by v squared, which is 2t minus 1 all squared. Now let's see if we can tidy this up before we put everything together. The top becomes 4t squared minus 2t minus 2t squared, all over 2t minus 1 squared. And if I tidy the top up even more, I get 2t squared minus 2t all over 2t minus 1 all squared. So let's put it all together and see what we end up with. So dy by dx equals dy by dt, which is this. So 2t squared minus 2t over 2t minus 1 squared multiplied by dt by dx, which is the reciprocal of this, and that would be 2t minus 1 squared all over minus 2. Now a lot of things cancel out here. That cancels out that, and this minus 2 is going to cancel out a factor of minus 2 from here. Okay, so that'll give me, overall, that'll give me t minus t squared. I'm just conscious of the fact that I've skipped an algebraic step here. Right, so we know these two terms cancel out, so I'm just going to tell you how I got from here to here. So that is 2t squared minus 2t, all divided by minus 2, which gives me, now 2 divided by minus 2 is minus 1, so that's minus t squared. And the next term will be a plus because I've got a negative divided by negative t, and all I did was write them in a different order to get the final answer. Now this next example is more like the type of question you might be asked to do in an exam. It says find the equation of the normal when t equals 0, when x equals e to the power t, and y equals e to the power t plus e to the power minus t. So to find the equation of a normal, we need the gradient of the normal. But to get the gradient of the normal, we need the gradient of the tangent, which means we need to know what dy by dx is. Alright, so let's go and do that first. So let's work out dx by dt. Dx by dt is a nice easy one. E to the power t just becomes e to the power t. Dy by dt is fairly straightforward as well. This first term is just going to be e to the power t, and this one here will be e to the power minus t multiplied by the derivative of minus t, which is minus 1, so it'll be minus e to the power minus t. Alright, so let's just work out dy by dx. Now dy by dx will equal dy by dt, so e to the power t take away e to the power minus t, all divided by e to the power t. Now if you're wondering why I'm dividing, that's the same as multiplying by 1 over e to the power t. And what I end up with is 1 take away e to the power minus 2t. Okay, that's because I've got e to the power minus t here, and when I'm dividing powers of the same number, I subtract the powers, so I subtract another t, and that's e to the power minus 2t. So that's what dy by dx is. Now when t is equal to 0, okay, so I want the gradient at that point, dy by dx will equal 1 minus e to the power 0. Now e to the power 0 is 1. So that becomes 1 take away 1, which is 0. Okay, so it's got a gradient of 0, which means it's a horizontal line, which means the gradient of the normal is at right angles to that. So if that's going to be horizontal, the gradient of the normal is going to be infinite, which means it's a vertical line going up and down like that. Okay, so I know it's a vertical line, so the equation is going to be x equals something. With that in mind, I just need to work out what the x-coordinate is when t equals 0. So when t is equal to 0, x would equal e to the power 0, which is 1, which means the equation of my line is just x equals 1. Okay, so I know it's a vertical line, so I don't have to worry about the gradient because it's just vertical. So all I need to know is the x-coordinate, and it's going to be x equals 1 in this case. So hopefully you've understood that. If you haven't, just listen through it again and hopefully it'll make sense. This next example is a bit more involved. We've got x equals 4 sine theta and y equals 2 cosec 2 theta. And theta is between 0 and pi, and that domain is going to be really important. Now there's a point A on this parametric curve, and that's got the coordinates 2 root 3, 4 root 3 over 3. And the first part is asking us to find out the value of theta at that point. And the second part wants us to work out the equation of the normal at that point. So let's deal with part A first. So we need to understand what this tells us. This tells us the x-coordinate, that tells us the y-coordinate. And that might be obvious, but what might not be so obvious is how we work out the value of theta. So what we need to do is plug this information into this first equation. Okay, so we've got 2 root 3 is equal to 4 sine theta. And if I rearrange that, I'll get sine theta equals, now remember if I divide by 4, I'll get rid of a factor of 2. That would be root 3 over 2. And if you know your angles, you'll know that the inverse sine of root 3 over 2 is pi over 3. But because the domain of theta is between 0 and pi, there's actually another angle as well, which is 2 pi over 3. So it could be one of these. Okay, so I need to be sure of which one of these it is. So I'm going to plug it into the y coordinate. So y is equal to 2 cosec 2 theta, which is the same as 2 over the sine of 2 theta. Now I need to understand something about my CAST diagram. So C-A-S-T. Remember, sine is only positive there, okay, and there. Anywhere else, it'll be negative, but my coordinate is positive, right? So it needs to be either an acute angle or an obtuse angle. And I'm talking about 2 theta here. So if theta is pi over 3, then 2 theta will be obtuse because that's 2 pi over 3 and that's fine. But if theta is 2 pi over 3, then 2 theta will be 4 pi over 3, which is a reflex angle, which would make the value of sine negative. All right, so it can't be that one. So the actual answer that we need is pi over 3. So theta equals pi over 3 is the one we're going to go for, and let's just get rid of that. Okay, so hopefully you understand why we're choosing theta equals pi over 3. And for further verification, you could actually just plug that into here. Let's just do that. So we've got 2 over sine of 2 pi over 3. So that would be 2 over, now the sine of 2 pi over 3 is the same as the sine of pi over 3, and that would be root 3 over 2. And that gives me 4 over root 3. And if I rationalize it by multiplying by root 3 over root 3, that gives me 4 root 3 over 3, which is this coordinate here. So we can be confident we've got that right. Let's go ahead and do part B now. We need to work out the equation of the normal at A. So to work out the equation of the normal, we need the gradient of the tangent, from which we can get the gradient of the normal, and then we can go and work out the equation of the normal. But to get the gradient of the tangent, we need to differentiate. So let's do dx by d theta first. Okay, so sine becomes cos, so that would be 4 cos theta. Let's do dy by d theta. Now I've got cosec here. Cosec becomes minus cosec x cot x. So in this case, it'll be minus cosec 2 theta cot 2 theta. But then because of the 2 theta, I need to multiply by 2 as well. So that would be minus 2 cosec 2 theta cot 2 theta multiplied by 2, which is minus 4 cosec 2 theta cot 2 theta. So dy by dx will equal dy by d theta, which is minus 4 cosec 2 theta cot 2 theta divided by, and the reason I'm dividing is the same as multiplying by 1 over 4 cos theta, so 4 cos theta. Okay, so that's what dy by dx is. Now what I can do here is I can plug in my value of theta to work out what dy by dx is at that particular point. So when theta is equal to pi over 3, dy by dx will equal minus 4 cosec 2 pi over 3 cot 2 pi over 3 divided by 4 cos pi over 3. In case you're wondering why these are 2 pi over 3, it's because that's 2 theta. Let's go ahead and work out what all of this gives us. So the 4's cancel each other out. Let's keep the minus there. The cosec of 2 pi over 3 is 2 over root 3. Okay, the cot of 2 pi over 3 is minus 1 over root 3, and that's all divided by the cos of pi over 3, which is a half. And what that simplifies to is 4/3. Okay, so the gradient at the point A is 4/3. But we have to be careful. Remember, that's the gradient of the tangent at A. I need the gradient of the normal, so the gradient required is minus 3/4. All right. Now we also need the point A, but we've actually got that. The point A is that point there, so we've got everything we need to plug into our formula. Y minus y1 is equal to mx minus x1. So y take away 4 root 3 over 3 is equal to minus 3/4 x take away 2 root 3. Now normally we're asked to work out the equation in the form ax plus by plus c equals 0, and that's what we're going to do here. So let's multiply everything by 3 to get rid of this 3. So 3y take away 4 root 3 equals minus 9 over 4 x minus 2 root 3, and then multiply by 4 to get rid of this 4. 12y take away 16 root 3 equals minus 9 x minus 2 root 3. And I'm just going to expand the brackets and tidy that up. So that gives me 12y minus 16 root 3 equals minus 9x plus 18 root 3. And move it all to the left hand side. I get 9x plus 12y minus 34 root 3 equals 0. Right, and our final example, we've got x equals 2 sine t, y equals root 2 cos 2t, and t is between 0 and pi. And we need to work out what dy by dx is, which by now you should be okay with. Part B, at the point A, t equals pi over 3, find the equation of the normal at A. So you should know the procedure for that. And for part C, we've got to show that this normal doesn't hit the line again. All right, and I'll show you how to do that in a little while. So let's do part A first. So part A, dx by dt. Now, if x equals 2 sine t, dx by dt will be 2 cos t. Dy by dt. Now, remember, cos becomes minus sine, so this is cos 2t, so it'll become minus sine 2t, but then we have to multiply by the 2 as well. So it'll be minus root 2 sine 2t multiplied by 2, which is minus 2 root 2 sine 2t. So that gives us dy by dx equals, so dy by dt, which is minus 2 root 2 sine 2t, multiplied by 1 over 2 cos t, which is the same as dividing by it, so 2 cos t. Now these twos cancel each other out, leave me with minus root 2 sine 2t over cos t. Now you might be tempted to leave it at that, but there's an identity we can use to actually help simplify this. Now that is actually equal to minus root 2. Now sine 2t is 2 sine t cos t. Okay, so that would be the same as 2 sine t cos t, all divided by cos t. So the cos t's cancel out, leave me with minus 2 root 2 sine t. And that is much easier to substitute any values of t into, which is what we need to do in part B. So at the point A, t equals pi over 3. So let's substitute that into dy by dx. That'll give you minus 2 root 2 sine t. So sine of pi over 3 is root 3 over 2. And what happens there is this 2 will cancel this 2 out, leaving me with minus root 2 times root 3, which is minus root 6. But remember, that's the gradient of the tangent. So the gradient of the normal will be 1 over root 6. So we've got the gradient, and now we need the 2 points when t equals pi over 3. So my x value will equal 2 sine pi over 3, which is going to equal 2. Now the sine of pi over 3 is root 3 over 2. Okay, so that'll just equal root 3. And the y value will be root 2 times the cos of 2t. So the cos of 2 pi over 3, which would equal root 2 multiplied by minus a half, which is minus root 2 over 2. So we can plug all this information into y minus y1 is equal to mx minus x1. So remember, this is my gradient, this is my x coordinate, and this is my y coordinate. So y take away y1, so y take away this, so it's the same as adding it, is equal to m, which is 1 over root 6, x take away x1, x take away root 3, and we'll try and tidy that up a little bit. So let's multiply everything by root 6, so root 6y plus root 6 times root 2 is root 12 over 2 equals, now this leaves me with x minus root 3, and let's just try and plug it all together. I'll have the x term, okay, I'm just moving everything to the right hand side, take away root 6y, take away root 3, take away root 12 over 2 equals 0, and I can actually simplify this last bit. Let's get rid of this. This last bit here, root 12 is the same as 2 root 3, so 2 root 3 over 2 is just root 3, so we've got root 3 take away another root 3, which is take away 2 root 3. Okay, so that is the equation of my normal. Now I haven't left myself much room to do part C, so I'm going to have to get rid of some of this. And I've just put the answer to part B over there on the left so you can see what it is. Now it says prove this normal doesn't intersect the curve anywhere other than A. Now in order to do that, what I need to do is I need to plug in this substitution for x and this substitution for y into this equation and try and solve it. So let's have a look. X, which is 2 sine t, take away root 6 multiplied by y, which is root 2 cos 2t, take away 2 root 3 equals 0. Now this is going to be 2 sine t take away root 12, which is 2 root 3, cos 2t take away 2 root 3 equals 0. So let's divide everything by 2 to give myself sine t take away root 3 cos 2t take away root 3 equals 0. And you need to know your trig identities to help solve this. So I've got an equation with sine t and cos 2t, and if I can write everything in terms of sine t, it'll make the whole thing a lot easier. So this is the same as sine t take away root 3. Now there's an identity for cos 2t, which is 1 minus 2 sine squared t, take away root 3 equals 0. I'm just going to try and solve this quadratic equation. Okay, let's expand it first. So I've got sine t take away root 3 plus 2 root 3 sine squared t take away root 3 equals 0. So as a quadratic, I've got 2 root 3 sine squared t plus sine t take away 2 root 3 equals 0. And I can try and factorize that, which is a little bit tricky, which is going to be 2 sine t, and over here I need a root 3 sine t. Okay, so that's going to give me my 2 root 3 sine squared t. I need to make 2 root 3, so I need a 2 and I need a root 3, so I just need to work out where they're going to go. Alright, so because the root 3 and the root 3, if I multiply them together, I'll get 3, and there's no roots in this term, it suggests the root 3 would have to go over here, and the 2 would have to go over here. Alright, and which way around is it going to be? This is going to be my plus, and this is going to be my minus, because I've got 4 sine t there, take away 3 sine t there to leave me with just a sine t. So what does that tell us? That tells us that sine t is equal to root 3 over 2, and over here I get sine t is equal to minus 2 over root 3. Now we know sine t can't be bigger than 1 or less than minus 1. Now root 3 over 2 is within that constraint, but this one here, if I think about it, this will be minus 2 root 3 over 3. Okay, and if I was to work that out, that would actually be less than minus 1. So that option is not valid. So from here, I get t is equal to the inverse sine of root 3 over 2, which is pi over 3, or 2 pi over 3. Now pi over 3 is one of my values for t anyway, and 2 pi over 3, I'm going to plug that in to see what values of x and y I get. And if I get the same values of x and y, that means it's actually the same point. Now when I was working out part B, the coordinates I got for the point A, if you rewind the video, you'll see were actually root 3, and it was minus root 2 over 2. That was when I had pi over 3. So what I'm going to do is I want to put 2 pi over 3 into these two equations and see what coordinates I get. So like I said before, if they're the same, then there's the same point. If they're different, then I've not managed to show that it doesn't cross anywhere else. So let's just have a look what happens. So x would equal 2 sine 2 pi over 3, which is 2 times, now the sine of 2 pi over 3 is root 3 over 2, which is just root 3. So far the x coordinate is the same as what it was before, so that's fine. The y coordinate, that would be root 2 multiplied by the cos of 2t. So the cos of 2t, that would be 4 pi over 3. So that would be root 2 times by, now the cos of 4 pi over 3 is actually minus a half. So that would be minus root 2 over 2, which is what I've got over here. So whether I use pi or 2 pi over 3, So whether I use pi over 3 or 2 pi over 3, I get exactly the same coordinate, which means that normal only hits that curve once. So that's part C done. And that's me done for now, and I hope those examples have helped you to understand how to deal with parametric differentiation and the questions associated with it. So I hope to see you next time. Goodbye for now.